In this video, we'll discuss how to calculate ion molarity. Ionic compounds can be soluble or insoluble in water, but when they are soluble, they dissolve and then the ions dissociate. So you have your compound, it dissociates into the ions that make that compound. When you're doing ion molarity problems, you need to know how many of each type of ion and the total number of ions because there's different types of ion molarity problems. Sometimes you solve for the chloride ion in this example, or the iron ion, or the total number of ions. But this example we're going to look at here, it's what's given is 0.29 grams of iron 3 chloride, and we also have the volume in milliliters. We're we're solving for the concentration of chloride ions, and we're going to assume moles per liter or molar. So your unit could be either moles over liters or your unit could be capital M. We're assuming this because it doesn't specify what unit we're solving for, so we always assume moles per liter if it doesn't ask for something other than that. We have to convert grams to moles. So 20.29 grams divided by the molar mass of iron 3 chloride gives us 0.001788 moles. And then we have to solve for liters because our unit is moles per liter. So 300 milliliters divided by 1,000 gives us 0.300 liters. Our equation for molarity, even though it's ion molarity, it's still molarity. So it's C is equal to N over V. We substitute our moles and liters into the equation, and that gives us 0.005960 moles per liter. This is the molarity of iron 3 chloride, but it is not the ion molarity, and specifically the chloride ion molarity. So this is the molarity of the compound, but not of chloride ions. Since we have 3 chloride ions for every iron 3 chloride, we have to multiply the molarity by 3, and that gives us 0.01788 moles per liter. If you use sig fig rules, we have to round that to 2 significant figures, so the answer is 0.018 moles per liter.